So, what'd you have to use on number 1, a T or a Z? T. Because the standard deviation I gave you came from the sample. Cool. And why was it normal?
Greater than 30.
Yeah, the sample size is bigger than 30. It's either 51, 61, 71, or 81. Okay. So, what I want to focus on today after we do whatever homework questions you guys have is I want to firm up chapter 8. Like section 8.2 I have to go back to, and there's a couple of definitions we have to talk about. And there's a whole idea of something called the p-value that we have to talk about. And I've got the practice test for the test that will be happening next Wednesday still. Because I'm giving my Calculus 2 students a test the following week, and I want to have enough time to grade stuff from one day to when I need to give it back to you. So I can't do that unless I get the weekend for everybody else, right? So I'm not going to touch that.
This next test covers 6, 7, and 8.
7 and 8, yeah. And the end of 6.6. Remember, I didn't do any NAB on that last test.
No NAB.
So there will be a NAB on this test. Yes, you must be tested on that stuff. There will be a NAB. An Nabisco product. No, a NAB, a normal approximation to the binomial distribution.
Can you go over 22 of page 398?
As long as I put my name on that quiz, do I get some credit?
Well, I noticed you spelled it wrong, Brian. So.
I spelled my name wrong. Minus 5 points.
Is that it?
Change the 6 to a 3.
0.5?
You went high road.
390. Whoa. Okay. So this one asks you to find the critical values, right? And that's all I want you to do. That's what I said 8.2 was all about, was some definitions we still have to cover. And they do like one piece of a hypothesis test at a time. So some of the problems ask you to calculate the test statistic, and that's it. And this one just wants to know what's the critical region, what's the critical z-score, the rejection, the boundary. So how many tail tests would this be? Why?
Because it's greater than.
Because it's greater. I only care about samples that are up there. So I can right now I can draw it. So how much area is in here? 0.01. I don't have to split it between two tails. There's only one tail. And this says assuming the normal distribution applies. So I don't have to worry about t-scores, right? They say assume the normal distribution applies. How do you find the z-score then? What's the easy way to do it? T-chart. Or just know it, right? In this case, it won't be quite that.
Oh, it's 2.575.
Won't be that either.
Damn it.
It's a good guess, but no. So look at 0.01 in the T-chart. 0.01 in one tail, go all the way down, right? 2.326. And that's the beautiful thing. Everybody cool with that? I am looking at a T-chart, but since I went to the bottom, that is a Z-score I get. And it's set up beautifully for hypothesis tests, right? One tail, two tail, bam. I can go right to where I need to. Is that cool? Okay, yeah.
Number 26.
Right below that one? In section 8.2?
Yeah.
So this one says find the value. Okay, this is like I was saying. All I want you to do on this one is to fill in this formula here, right? And work it out. So they say the claim is that less than half of adults, blah, blah, blah. I thought it said KFC for a minute. Like, what the hell would KFC want to do with carbon monoxide? So they surveyed 1,005 adults, and they resulted in 462 who have carbon monoxide detectors. So why did they tell me that first piece? Why did they have to tell me the claim? In this particular problem, all they want from me is what I call the Z star. Right? I call this one the Z star. That's all they want from me. What's P hat? What's P hat from what they tell me?
Divide 314 over 1122.
11. Well, 1,005, right? Which problem? We're on 26, right? Am I doing the right one?
462.
Out of 1,005, 11. Right. So what did we see in our sample? We saw 462 out of 1,005.
2460.
Okay. But now that's just one piece of the equation. Where do I get the rest of it? What's P? What would my claim be?
P is 1204.
What's it say? It says, is that less than half of adults, blah, blah, blah. So what's the claim?
Less than 50%.
Okay, so what's less than 50%? Right? The percentage of the population is less than 50%. Because what's the little hat mean on a P? That means it came from a sample. So the P without a hat came from a population, right? The sample P's are a little bit looser. They wear their weird looking hats, right? What would the HO be in this case? What would the null hypothesis? What would the HO be?
Less than 25. Less than
What does the HO always have to have?
equal.
So this, since that's less than, this will be P. Okay. So what I'm trying to get you to understand is you're going to have your data from the sample you took, and you got to compare it to this which comes from the claim. So I'm going to put a 0.5 there. If I'm trying to show that what I found is less than this, I want to subtract that from this. I want to see how far apart they are. So to finish out that formula, I can find P hat, but you got to understand that P comes from the claim. That number right there. I want to compare it to this number here. So when I go to fill in that formula, it'll be my P hat minus the thing I'm comparing it to. Now what goes in here?
0.5.
I love it, right? What's P? It's P and Q, not P hat and Q hat. It's P and Q. So it's 0.5, and of course Q is 0.5, and N was 1,005. Bam. So if you put it in just like that, you should be good.
Can it come out negative?
Okay, what's about a z-score? A z-score for a mean is always...
So 30.
No, what's a z-score for the mean? 0. And if it's above the mean, it's... If it's below the mean, it's negative. In fact, in this case, I want to show it's less than. It better come out with a negative z-score then, to be below it, right? See, this is what I meant by I don't like doing this until you've seen a full-blown test, because by itself it doesn't really make a lot of sense. You need everything else to kind of come into why it makes sense. Hopefully you guys see that. So this is that one. This is like just doing step 4. This is only step 4 from our hypothesis test, right? Where we do our sample information. This would be only doing step 3. Setting up the rejection region, right? So A2 breaks it down into little steps, focusing on each step. Okay. So any other questions from, yeah?
How did you get 0.5 and 0.5?
Well, the P is 0.5 because that comes from the claim. And if P is 0.5, Q's got to be 0.5 because together they got to make 1. The biggest mistake is people will put 0.46 and 0.54 in here. The formula calls for P and Q, not P hat and Q hat. No hats on those percentages. Okay. I'm so happy that I could cause you to be this excited.
You're looking at blank faces, aren't you?
Well, obviously, we're going to do several examples of hypothesis tests. And through doing the hypothesis test, I'm going to show you the definitions and the little side stuff that A2 has. Yeah.
Maybe 30.
Okay, so that's the part that we haven't done yet. Yeah. Okay, so like I said, I kind of did everything else, and I was going to come back and finish out A2. We haven't talked about the p-value yet. I made reference to it on that handout I gave. Maybe some of you guys have read it, but we're going to focus on that today, seeing what the p-value is and what it means. So let's do this. Let's do a problem, and we're going to do it all the way out. We'll figure out what the p-value is, we'll figure out what the hell it means, and I'll try to throw some definitions in there. Any preference on what section you want it to come from? You want to do a T1 or a P-hat 1 or a P-hat? Okay, that's the first thing I heard. Too bad. That's the A3. So page 410, let's do... That sounds good. Page 410, number 17.
What section is it?
A3.
So last Monday, or this past Monday, we did A4-ish hypothesis testing. Now we're moving backwards.
We've been doing all three. A3, A4, A5.
Got it.
All right, this is number 17. This is one about cheating gas pumps. Screw this thing. If you don't have a book, get cozy with somebody who does. Or not cozy if you don't want to. Just eyesight, right? Make sure you can see it. So they were testing gas pumps in Michigan. These fuel quality enforcement specialists found that 1,299 of them were not pumping accurately, and 5,686 were accurate. Blah, 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 blah. Tests that claim that less than 20% of Michigan gas pumps are inaccurate. Okay, this one's a good one for semantics, I tell you. So I want to see that less than 20% of them are inaccurate. So how are we going to write that claim that's being made? Do you notice what information do they give me that's really unnecessary information for me to do this problem? I love it. No. Does somebody say all of it?
Something about Michigan.
They had described what accurate means, didn't they? Within 3.3 ounces in fan gallons. That's not going to show up in my work at all. That's just what accurate means, right? Well. So what's the claim? How do I write the claim? Less than 20%, right? So what would that look like in Mathish?
We get less than 20.
I like it. All right. 0.2 or 0.20? And it only makes sense. It's the first thing you want to find is your claim because that sets everything up. Without that, there's no reason to do anything.
And your O is E greater than
All right.
equal to.
Yeah, because this will have to be the high because it does not have an equal sign in it. And the O's got to be the opposite of that. Which, like you said, is greater than or equal to 0.2. Okay. So again, this just says, what the hell are you talking about? Just tells people, what the hell am I talking about? I'm talking about this. This is a situation I got. How many tail tests will this be? One tail test because
Less than.
it's less than. I only want one side, right? If I get on the other side, I wouldn't do anything. It's just one side that will show me evidence of this. It'll be down here. What's the second step?
Rejection.
Not quite. That's the third step.
What you can use.
What am I allowed to use? All right, so in order to define the rejection region, I have to know first, can I use Z's or T's? Or can I do anything at all? So Z, T, or nothing. I'm curious to see who remembers what you have to do here. Don't tell me the n's bigger than 30. That doesn't mean a damn thing here. Who remembers what you got to check for an NPQ problem?
Population deviation.
NP and NQ.
Greater than
Q, Jeff. It's going to be greater than 5. And right, so let's check it. What's N? Here's another place. This problem actually is a really good one to talk about. It's got all kinds of little mean things. What is N? Yeah, you got to add them up, right? So if you add them up, what do you get? 6, 9, well, I don't know, 6, 9, 8, 5? Is that right? Okay. So it'll be 6, 9, 8, 5. Don't you remember that? They did that to us a while back. They said like 16 people got a headache and 40 people didn't. What's the probability you get a headache? Well, you got to add them up first, right? They didn't give me a total. So that's the total number. What's P? We already told it to ourselves. 0.2. And of course, 20% of that's going to be bigger than 5, ain't it?
Yeah.
What's it going to be? It's going to be like 1,400, just under, it's going to be 1,396. 7. That's bigger than 5. So obviously this one, what would this one be? 6, 9, 8, 5 times what? What's Q?
0.8.
0.8. That's, well, I don't care. It's going to be bigger than 5.
5,588.
Cool. That step is equivalent to saying n greater than 30 for a mean problem. For an NPQ problem, this has got to be true. So I will ask you to check that. So what can I use? Z. In fact, it's never T for an NPQ problem. Either it's normal and we use Z's, or it's not normal and we don't do a damn thing. Okay. Standard deviation, why does that not matter? They didn't tell it to me. I can make my own damn standard deviation. Right? Square root of PQ over N. I make my own. I don't need them to tell me a damn thing. That's why I never have to use T-scores for an NPQ problem, because I always have the standard deviation. The population, I always have it. I never have to use a T-score then. Okay, so what the hell are you talking about? What are you allowed to use to talk about it? Right? That makes sense. Good first steps. Now, what's step 3? Yeah. Rejection or critical region. Whew.
Still getting high.
Oh yeah, I know, yeah. So what do I have to know for this? We know we can use Z-scores.
Needs to be your
Alpha is what?
0.01.
0.01? Cool. How many tail test is it? 1 tail. And that's all I need to know. And it's 1 tail down here. So what's the area in here real quick? 0.01, of course. And the Z-score that corresponds to that area in the tail, I must be saying it that way for some reason.
2.575.
It's the same one that we had earlier that nobody guessed correctly.
2.362.
Yeah. So if you look at 0.01, 1 tail, Z-score, 2.326 is what you'll get. I know some of you guys are doing, you're thinking 1% is like 99% confident. No, it's not. That would be 1% in 2 tails. This is 1% 1 tail, so it's like a 98% confidence interval. 1% there, 1% there. Don't even think about it. Oh, you just look the damn thing up. So how would I say this in words? What do we have to find from our sample? If our sample Z-score, Z star, is less than this,
We reject the O.
then reject the hoe. Support the high. If not, you fail both, right? Okay. So what the hell are we talking about? What can we use to talk about it? What's enough to show me evidence? And then let's go see if we got the evidence, right? So what do we know about the sample? What was N?
6985.
I love it, 6985. What's P hat? Now this is where you got to be careful now. What are we testing? That the less than 20% are inaccurate. So what percentage of our sample were inaccurate? Well, that's the claim. But what exactly percent were less than? What exactly were inaccurate? What percentage? How many out of?
12.99.
Yeah, 12.99 out of.
690.
And whatever the hell that is.
18.5%.
0.185?
Or 0.186.
186? Is that what you guys are getting? Double check that. Because I always have somebody like 5 minutes later say, no, that number was wrong. Tell me now. Okay. And now I got everything I need. It's kind of freaky. You don't need so much information for this z-score problem because it's using all these P's and Q's. I don't have to have sigmas and all this other crap. I just need p hat, which we got, minus p, which we got 0.2.
That's Z star.
Yeah, z-star thing. Yeah, there. So obviously, if I'm testing a claim about a percentage, I want to use a Z formula that has percentages in it, right? So on one level, some of this is pretty simple about which formula do I use. So let's see if we all get the same thing. Of course, everybody's cool with where I got that 0.8, right? Oh, okay. I don't like the calculator that I have, so I'm going to wait. Okay, I'm going to try to stop doing it in my head. What do you get?
Negative 2.925.
Is that what
Yeah.
everybody else get? Okay. Okay, cool. So going back to my rejection region, did we make it far enough?
Yep.
Yeah, cool. We got, so here's my Z star. We got here, negative 2.93, I guess, right? So right there, what can we say? Real quick thing, not even the whole blown out thing. What's a quick thing you can say? Did we reject? Did we fail to reject? What can we say? We definitely rejected because we got into the rejection region. What a beautiful name for the thing. If I get in it, I reject. If I don't, I don't. So we got into it, so we reject the O, which means I could support the I. Now let me put this in here right now. How did the alpha relate to this 2326? How do they relate to each other? I said it earlier. How does that alpha relate to the critical value? How do they relate it? How are they related? That critical value has how much area in its tail?
0.01.
Alpha, right? That's how they're related. The critical value is the z-score that has alpha amount in its tail. Is that cool? Of course it is, because we looked the damn thing up to find it, right? So it's like, well, that's amazing, Jeff. Cool? The p-value is the area that's in your z-score's tail. So how do you find, now this is a really old question, how do I find the area in the tail of this guy, the negative 293? Just look it up in the chart, right? Doesn't the chart tell you the area below? So look up negative 293 in the z-score chart. What do you get? Make a bigger picture of that for me. Alpha is the area in the tail of the critical z-score. The p-value is the area in the tail of your z-score. So, does somebody have that number for me? When you look up negative 293, 0017, right? Okay, I really want you to understand this. This is not a big deal here. I got the answer already. I know what we're going to do. That was far enough away, great. If I go the extra step of looking up this p-value, it actually gives me more information. It tells me exactly how unlikely this is. Because that's the whole idea. If I do something that's really unlikely, given that they're right, they're probably wrong. So if they say, I think most people can fly, and 1,000 people jump off a building and die, that's evidence that that guy's probably wrong. I don't know why I didn't instantly go to something morbid like that, but oh well, too bad for me. Is that cool? So we got the answer. The p-value, how does it relate to alpha? Which one's smaller? For this case, the p-value is smaller than alpha, right? So if the p-value is less than alpha, you reject the hope. Now that sentence is just so full of new words, it sucks, but I really want this to make sense. If the tail your z-score makes is smaller than the tail the critical, you must obviously be in the rejection region, right? If your tail is smaller, you must be in there. So if your tail is smaller than the alpha, you reject the hope. You're far enough away. Very often, in real life, we will not have an alpha. There is no alpha in real life most of the time. Most of the time, we're just doing exploratory research, and we just give people the p-value so you can make your own mind up. So if a p-value was 0.000000002, what could somebody tell me? What do you think? Tell me more. Do you think they rejected the hoe or not?
They rejected the hoe.
That p is damn small, right? So I don't care who you are. You're going to say, well, they showed evidence of whatever they're talking about. If they're trying to show a correlation between the age at which kids learn to talk and the IQ of kids at a later age, if they have a p of 0.00002, I'm like, well, they showed the damn correlation. They got it. They did it. If they got a p-value of 0.3, nah, screw that. What's the biggest alpha we've seen so far? What's the biggest level of significance we've really seen? 0.10, right? Alpha 0.10. So a p-value of 0.3 is way too big. It's a big old tail. Ain't no way it's going to be in the rejection region. So when you read an article, when you read a journal article, so I'm going to bring a couple next time, you will see p-values referred to throughout. And normally if they're a p of like 0.00005 or something, that what they're saying there is they say, we have found a lot of evidence to support what we're trying to do. They could say that very quickly by saying p is 0.00005. There. Nah. We've shown evidence, right? Okay. If some of you guys, how many of you guys are going into any business-related field, possibly? All right, p-values are used very often in business. It's true, believe it or not. I've had people come back to me a couple last semesters after taking my stats class and saying, yeah, we just did the freaking p-value crap in the business class. I'm like, don't call it crap. But then they'll come back and verify. I'm like, okay, good. I told you, right? I really don't know if truly that p-value is the person, the thing that tells me what's going on. That's so unlikely. It disproved the hoe. It disproved this. So how are we going to word the conclusion now? Let's get past the p-value for a second. How do we word this conclusion? What's the claim? Which one was the claim, the hoe or the high? The high. So I would word it, support the high. So I'm going to say we have found evidence, support the claim. Now if you like the flow chart, or if you like the whatever the hell to figure out how to word something, use it. Personally, you told yourself how to word it right there. Support the high is the claim, that's how I'm going to word it. So step 5, we have found sufficient evidence. support the claim that less than 20% of gas pumps were inaccurate, right?
Inaccurate.
Yeah. Which is still, I'm sorry, but 18% of gas pumps inaccurate, that's kind of troubling, right? In fact, one guy once did a study and they said the faster you pump it, the more inaccurate it becomes. So ever since then, I kind of like set it on the next lower level. Let it kind of go, and I go do something else. Science fairs?
Somebody did that for a science fair.
So,
Tested the accuracy.
and did they, do you remember, did they show that? Did they find
a lot of inaccuracy.
the faster the pumping, or?
Yeah.
Okay. Oh yeah, just general inaccuracy, sure.
The aeration? The aeration?
I don't know, it's just the mechanism that monitors how much is coming out. It can't keep up or something. I don't know. Okay.
So what's the best we tap it?
Yeah, just make it go slow. Right? Don't tap it, just let it go slow. One other thing here. Let me see if you guys can get this. What could be true in reality here? What could be true? Independent of the sample I took or what I think is true. What could be true? So all the gas pumps in Wisconsin, what percentage of them could be inaccurate? It could be less than 20%, or it could be greater than or equal to 20%, right? No matter what I find, there's always a chance I'm wrong. What kind of mistake could we have made here? What did we do here? What did we do with these? What did we do? We rejected this guy. If I made a mistake, what would that mean about this guy? He'd be true. So one type of mistake you can make is to reject a true null hypothesis, right? Reject a true hope. Here we go. So there's two types of errors. There's one, type 1 is exactly that. And I hope the guy you understand. There's only two stances. So there's only two types of errors we could possibly make. If you reject a null, you might have rejected something that was true. So just because we rejected the null, I really want to make this point, doesn't mean it's false. It just means it seems to be false. We've seen evidence that it's false. Doesn't mean it is false. There's a bunch of innocent people on death row. We know that. But it's give and take, right? I don't know where else, I don't want to get into that controversy, but so type 1 error would be rejecting a true null. Obviously that's a mistake. There's no way to know it though, is there? If you can't get the whole population, there is absolutely no way to know if you made a mistake or not. That's statistics. You just can never know. So what do you think the other type of error might be? If we would have failed to reject, careful, careful. If one is rejecting a true, the other one must be failed to reject a false. Okay, Jeff. I'm not sure what language. Fail to reject a false. Falso? There we go. Right? Does that make sense? Those are the two things that could happen. If you reject something, it could have been true. If you fail to reject it, it might have been false. So in this case, we could have made a type 1 error. The probability that I can make a type 1 error is equal to no. Because that's how much area I accept as being unusual. What's the chances that everything's kind of running in here together. What's the chances that any sample falls in here if this really is the right place? Well, what percentage of the samples are in there? 1%. So the probability that any random sample I pick falls in there is 1% chance. But what's more likely then? If I do find something in there, there's a 1% chance he's right. So what's more likely? He's wrong. That's what we just said. We've shown evidence. 1% chance I'm wrong, but damn, those are good. I like those probabilities. I like that. Yeah.
So did you say the probability that you're wrong is equal to alpha?
For a type 1 error. So type 1 error, alpha is the probability of a type 1 error. The type 2 error is it's quite a bit more difficult to get. It's actually, the symbol is beta, the next letter in the Greek alphabet. We're not going to worry too much about it. It's related to what's called the strength of a test, but it takes a bit more work to get at. Obviously, if I make alpha, like if I didn't want it, if I want the possibility of me making that mistake less, what would I do with alpha? Make it smaller. I want to decrease the probability I make that kind of mistake. But if I decrease this kind of mistake, what do I do with this kind of mistake? So it all depends on which one's more crucial, right? So one example I love to give about these type errors is, let's say you're a medic on a battlefield. And there's all these people laying on the ground. You have no idea what's going on. What do you think your assumption is? If you're coming out there and you want to help people, what's your assumption as you approach somebody? What are you assuming? What are you going to try to disprove?
If they're alive or not?
Yeah, my no would be they're alive. If my no is they're dead, I'm not going to go out there, right? Or you can actually set it up either way. So let's say the null hypothesis is they're alive, and the alternate is they're dead. So if they're alive, what am I going to do? I'm going to try to help them. If they're dead, I'm going to go to the next person. It's too late. I'm sorry, right? So what's the type 1 error here mean? In words, what would a type 1 mean? So reject the true hope. You think that they're dead, but they're actually alive. Cool? And the way I remember this, and I'm not really going to be that crucial about type errors, but type 1 is the smaller phrase, reject the true. Type 2 is a longer phrase, fail to reject a false. That's the way I remember it. Not the most exciting thing in the world, but oh well. So type 1 error would be, I think they're dead, but actually alive. So what am I going to do? If I think they're dead, I'm going to leave them and go to somebody else. That certainly sucks. So I feel for a pulse. Their pulse is so slow, or I'm so amped up myself, I don't feel anything. I don't think I feel anything. So I go to the next person. Right? Or check for breath, and the breathing is so shallow, I miss it. Right? So what's the type 2 error here?
You think they're alive, but they're not.
Yeah, think they're alive, but they're actually dead. So what am I going to do here? What will I do here in this case? I'll stop and I'll try to resuscitate them. They're already dead though, right? Okay. Do you guys, and which one is worse is kind of difficult to tell in this case, right? Which one of those is worse? If you're this, that sucks for the guy who just passed up. He's like, wait. And if I'm this, that sucks for the next guy because you're wasting time, right? And I want to apologize. This is a good example of a crucial situation where making an error is big. So you want to be able to control the error, but both of these errors are bad. Which one? Any suggestions on which one's worse? I would say that's worse. Because this one, if you think they're alive, you might realize as you work, oh wait, they're not alive. This one, you're not going to even try. You think they're dead, you're not even going to come back to them. So I would think this would be worse, so you want to make alpha small, so you don't make this mistake so much. Right? Okay, so I'm just about out here. Did I give you guys the practice test yet? No. Let me do that before I forget. I did something new. I just put it all on one sheet. You can use your own paper to figure. I have no idea how much room you're going to need, so I'm not going to try to guess. We have no time for another quiz. Yeah. You don't make any corrections, you don't get anything.
No.
When I correct it, you do better than the test. You're going to go up. The better you know the corrections, the more you grade.
It sounds like you're doing everyone.
Because you got all the corrections. You get half the corrections right. It's all the syllabus. As long as you make corrections, you got something right.
Sorry.
Thank you.